transformations. So our objectives here is given the graph of a function, graph its transformation under translation, reflection, stretching, and shrinking. So here is some images of examples of different types of functions being graphed. So on this first one here, let me get my highlighter. This first one here, we have y equals x. This is what we're going to get. Everything I plug in for x will yield out a value for y, and we plot it, and we get this linear function. Y equals x squared. Well, we're going to get a parabola, and since we have, and let me give you a little note right here, right, helpful note. Since we have y is equal to a positive x squared, we know the parabola opened upward. If we had y equals a negative x squared, the parabola would open downwards. Now, we have y equals the square root of x. So we're going to get some value, depending on what's inside right now. It's just x. So that means x is greater than or equal to 0. And so that means all values from 0 and out will make this function. Then I have y equals x cubed. So everything I plugged in for x, I cube it. It gives me some y value. My apologies, my clicker kind of got a little crazy on me. We get this right here. So I would create XY tables and plug in points just so how you can see how it works. If you have y equals the cube root of x, we get this type of function. If I get y equals 1 over x, well, we get this function that goes on both sides of where we are restricted. So if x is in the denominator, we set it not equal to 0, and that gives me the restriction. That means that function will not cross whatever causes that domain to be restricted. So whatever causes my denominator to not be real, then that's where I'm restricted at. My function will not cross there. I'll have something happening on both sides of the function though, or on both sides of the restriction. If I have y equals the absolute value of x, then we get this right here. Now, when we start plugging in stuff all around this function, it starts changing the way this looks. It stretches, shrinks, moves, flips, whatever it may be. So these functions can be considered building blocks for many other functions. We can create graphs of new functions by shifting them horizontally, vertically, stretching, shrinking, reflecting about the axis. Now let's consider the transformation. All right, so in this one here, it says that b is greater than 0, that we have this a graph of y equals f of x plus b, right? So they said, oh, well, this red function here is this equation. And then this one here is the black one. It said is the graph of y equals f of x. So what happens? Let's just talk about this a little bit better, okay? It's doing this in parts, which is good. At the same time, it can be a little confusion. So if I have this function going on of f of x, y equals f of x, my b tells me that the function shifts up. If it's negative b, it's telling me it's shifting down, and that's what they're telling you here. Okay, so now they said, okay, let's focus about this here. If I have y equals this function of x minus d, this is my original, and then that means that my function will move to the right. If it's this that we have, then that means in order for it to be original, my x minus that d would mean that d is negative. So that means it would move to the right. To the left. Sorry, to the left. So if d is positive, it's going to move to the right. If D is negative, it's going to move to the left. So now if we have y is equal to a negative f of x, then we're going to have a reflection about x, meaning that it's going to flip it about x, one of the two. If this is negative x inside this f of x, then we have a reflection about the y-axis. So we have something like that going on. So point x comma y is a graph of y equals f of x, where x negative y is on a graph of y equals f negative x, and so on. Okay. Now, it says, let's take this function here, x cubed minus x, or 4x squared. And we're going to graph each of the following before doing so. Describe how each graph can be obtained from the graph of. So what they did first is they plugged in the negative x to see what happens. So when I take negative x cubed, that doesn't change nothing. It's still just negative x cubed. And then when they squared this negative here, it becomes positive, and then negative 4 times that positive. Well, this is what I get. Okay. So now we got, and they said, let's do the same thing here with this one, which means let's make the whole entire function negative. So what happens? They just rewrote it and they skipped a step. So now I have what? Negative x cubed minus that 4x squared. I put it in brackets and distribute the negative sign. So now we got negative x cubed plus 4x squared, and they just rewrote it in that format. Okay, so when we rewrite it in the format, now we see is f of negative x is equal to g of x. So what do we got? We end up with negative x cubed minus 4x squared. And that's this one. That was A. Oh, so this is across the y-axis. It reflects about the y. And then here's your graph. You can graph it. And then when we do this one here, when we did the part B over there, where we said, okay, let's put it on the outside of that function. What do we get? We call it h of x. And then we notice it's a reflection about the x-axis. Okay, sometimes it's easier to graph it to see it. Sometimes it's easier. So get your graphing paper and scratch paper, create your XY table, plug it in, and move them. All right. This is telling me that if A here is obtained, and A here is greater than 1, so basically meaning if I put it on the number line, anything greater than 1, all positive numbers, then we're going to have a stretching vertically. Okay. If A falls between 0 and 1, so it's less than 1 but greater than 0, then we have a shrinking vertically. Okay. If A is less than 0, that means A is a negative number, then we have a reflection about the x-axis. So if my function starts out with negative this, so A is negative, well, we have a reflection. That means it's going to flip. Then we look at the number. What is A? So if it's a half, then we know we have a shrinking. If it's a 2, we know we have a stretching. So that's one way to look at it. So I'm going to do a breakdown. I'm going to give you a formula right quick. Maybe it'll help us. So let's recognize that our original says that x minus h. So h is positive here. In order to make x plus h, it means h would have become negative. So A here determines if we stretch or shrink. Okay. It stretches if A is larger than 1. It shrinks if A falls between 0 and 1. Also, something else about A, if it's negative, it flips about x-axis. And the reason is because we got y equals that. It's x involved here. And if we switch that up, we're going to change a whole lot of other stuff. So we'll get to that one of these days. H here, if it's positive, move to the right. If it's negative, move to the left. K here, if it's plus K here, then that means K is positive, right? You move up. K is negative, you move down. So that's what's going to happen to the function. You're going to be given a function and you're going to shift it. So in this case here, on my example I plugged here, we would use y equals x squared. We'd actually plot it first. 0. If I plug in 0 for x, I get 0 for y. If I plug in -2 for x, I get +4 for y. If I plug in +2 for x, I get +4 for y. So that is 1, 2, 3, 4. This parabola we get, that will be the original for this. That's why at the very beginning I showed you all those graphs. And if it was y equals x or square root of x, we'd go to that particular graph. This one here is what we're working with. So when I plot it, and we take that x squared and we plug in something for a other than 1. We plug in something for h. And we plug in for something for k. Then we're going to say, okay, does it shrink this graph here? Does it flip it? So that's A. Does it shrink it or stretch it? Does it flip it? H tells me we move to the right or to the left. And K tells me if we go up or down with this function. And so this is what it's showing you, that you had your original function here, and then they applied some other stuff to it and it moved it. So creating an XY table will be really helpful to you. This here is just telling you some more information about the shrinking and stretching horizontally. This says here that if your C is on the X and your C is greater than 1, then we're stretching horizontally. If C falls between 0 and 1, we're shrinking horizontally. If C is greater or less than 0, we reflect about the y-axis. Okay? So these are some examples. So let's go back. Let's just do one. So other than these here that's given. So what if we had y equals -2x plus h squared minus, I meant to put something in for h. Give me a second. Three. All right. Now the original formula I was talking about. Okay, so we know this is a negative, so we have a reflection about x. This is greater than 1, so we know that we have a stretching. The original formula says x minus h, and we got a plus here, so that means it's a -4, right? Because x minus -4. So we're going to move to the right 4 units. Oh, I'm sorry. It's negative, not right. We're going to move to the left, -4 units. And then this here, remember it was plus k, but it's a -3, so that means it was a negative. So we're going to move down 3 units, okay? So what you'd do is you'd take your original and you would plot all these changes to the original. We would flip this about the x-axis, right? So now it becomes like this. We would take these, every one of these order pairs and drop it down 3 units. And then we'd take it and shift it to the left 4. And then we'd apply the shrinking, or excuse me, the stretching. Thank you.